All right. Good day, everyone. Welcome to today's community events. And our topic for sorry. Good day, everyone. Welcome to today's community event. And the topic that we have before us today is data science for blockchain. And just to give you a little bit of overview about the topic, you say data science is a fast-growing field of technology. It helps to give interpretations to data and can improve decision-making processes in industries and ensure optimized operation. It is important that data got it's important that data is gotten and data gotten is secured and pure before it can be used. Blockchain is essentially a distributed database that ensures that data is secured and transparent, which makes it the ideal for a broad range of process. Data science and blockchain technology ensure we get data of high quality, which results in better analysis and accuracy. It also aids data exchange, trusted information or data integrity, and so much more. And in today's community event, we will get to hear our speaker elaborate more on this topic laid before us today. So we'll get fastened up and have a great time today. We welcome our first speaker to take the podium as he speaks to us today. Welcome, Mr. Wisdom.
Hi, good afternoon, sir.
Yeah, good afternoon.
And so I'll be kicking off. I'll share my screen now so we can quickly begin. Okay. All right. So good afternoon again, everybody. My name is Idris Wisdom, and today we'll be discussing briefly about data science for blockchain. So generally, I'll be giving an overview of what data science is and what blockchain is, and how both of those fields can interact and help each other. All right. So yeah, generally, when we speak about data science, we are talking about making data useful. We want to make some form of information that we have. It might be information about food, information about maybe transactions. It might be about maybe business sales, medical records. You might be studying maybe how much male children are given birth to in a particular location compared to females, and maybe there's a reason why. It's all information. So in data science, what we do is, okay, we get all of that information and try to make out some meaning from it. So at the end of whatever data science process you are doing, you want to make some form of prediction, or you want to make some form of decision, or you want to say, okay, this is why this happened, or why this did not happen. So in data science, we're majorly concerned with being able to make valid conclusions or gain insights from data to solve real-world problems. So data science is generally aimed at solving problems. So we always look at, okay, with this data, what problem can this data solve? So maybe we notice let's say a sales company, for instance, and they notice the sale in a drop in performance, for instance, let's say a drop in sales or a drop in profit or revenue they are generating. Now, we might want to make some kind of, okay, is there a reason why this is happening? Is there a trend? Okay, is it because they reduced, okay, maybe there was a reduction in a particular quantity or a particular quantity in their product. So let's say they were selling maybe oil, for instance, and they were selling about, let's say, a liter of oil at the price of 1,000 naira, and for some reasons due to production cost and all of that, they decided to drop their quantity to about, let's say, 750 mil at the same price rather than the data. Then did that correspond to, it was that the reason customers reduced purchasing that particular product and opted for something, or was there a decline in the quality of whatever was produced and it made customers do that, or is it related to customer service? All those things can be collected with data if they are well recorded, and you can make some predictions and say, okay, because we reduced the quantity, it led to a reduction in customers. Why don't we probably drop the price also and see if that works, or let's improve quality or whatsoever. Or can go as far as making some form of advertisements to maybe explain to customers maybe why at times it works. So data science generally wants to solve problems like that. Okay, why is this occurring? Why is this not occurring? Then with the data we have, we can draw conclusions. We are looking for patterns. We are looking for trends. Was there an increase? Was there a decline? Was this a cause of this, or all of that? Now, because in data science, we are majorly concerned with data, a lot of problems comes with actually working in data. So we are majorly concerned with making use of data to make meaningful decisions. Data gotten must be of good quality, transparent, and authentic, amongst other things you need from data. So this is where the problem majorly is. Okay, before we get into that, so we are seeing a data science workflow. We see acquiring. So explore the problem. So you want to get the problem first. You want to identify data, import the data. So you want to explore the data, visualize, and clean. So you're basically just processing the data. You want to remove unnecessary noise. So are there some things, incomplete data, missing values? You want to get rid of all of that. So you want to make sure the data is clean, is well organized, is well structured. The next thing you want to do is analyze your data. At this point, you're doing some data science techniques. So you're doing some analysis, you're doing predictions, maybe some regression, or maybe even applying some machine models to your data, whatsoever works depending on the kind of data you have. Then you want to present your findings. You want to visualize your results. You want to, okay, yeah, so this is what I can see. This is the trend. So that's why we are usually, you see graphs, you see line charts, bar charts, some form of pictures. So when you type in data science and you just click on images, what you would see is probably a lot of people, maybe one guy with a computer pointing to a graph or pointing to some form of information, usually numbers. Usually visualization is what you see when you make searches for images in data science, because that's what people understand. The goal of everything you've done is to present it in a way that is understandable. So that's why we have statistics coming into play, your bar charts, your line charts, your pie charts, regression lines, and whatsoever. There are all lots out there. Then the next thing is the action. So you want to make use of whatever you've done to achieve a goal. You want to make some form of decision. You want to do something with that information. All right. So now we're talking about, I was saying previously about the kind of data we have seeking for data might be a problem when it comes to data science. Now, one thing about having data is the data must be well structured. So it must be well organized. It must be, it must be secure, it must be free from maybe all this malicious manipulation and all of that. So let's start with data authenticity. So generally, in data science, we get data from a whole lot of sources. We pull data from many locations at once. So, and at times, some of these are vulnerable to tampering and can increase the likelihood of data breaches. So some of these data are not so secure. Some of them have been tampered with, some of them contain leaks and all of that. So in seeking for data, it's likely that you're opening up yourself to data breaches, especially when you're pulling from all different sources at the same time. Let's say maybe pulling from one API, pulling from that API, pulling data from all sorts of sources. At times it's not so secure, then it can allow your work to be easily breached, particularly maybe what you are pulling your data with is sort of going to be incorporated with maybe user information and all of that. You might be opening up yourself to attacks. So the next thing you might want to look about is data privacy. So one major concern in data science is user data. People want to know if their information is secured, even particularly maybe in the financial institution. People want to know their data is secure. People want to know their data is safe. Their information has been kept somewhere, and nobody's going there to tamper with it. But it can raise an issue, particularly you trying to do a research, maybe on maybe with financial data, for instance. Getting that kind of information might be difficult because of a lot of laws and legislation that was put in place to make sure people's information is safe. Okay, sorry. Another thing is data quality. Now, when we talk about data quality, we want to make sure your data is okay. Now, data can be messy or dirty. When I mean messy or dirty, it might have a lot of unnecessary information. It may not be well structured. Some values might be missing. Some values may not be accurate. All of that might hinder a data scientist's work. So generally, a data scientist does not want to work with messy data. So his first job is probably to clean up the data. If it's clean, working with messy data is just unnecessarily difficult. So most times, data scientists want to work with clean data that is well structured, and all of that. So all of these things might come into play as a challenge in data collection. So yeah, so we can see here we have discovery, difficulty in finding patterns and insights, data quality, storage problem, security, keeping data secure, analytics, and all of that. So they are all problems. There are so many more problems we can have in data science. Another thing is data availability, high volume, security, consistency, data quality. All of those are problems associated with data science. So now, generally, we've seen some of the problems a data science might face, particularly with data collection. Now, it's going to be nice, imagine if we had a system or some form of database to say that that does not just give you high quality data, but gives you data that is secure, allows easy access. It's transparent. You can trace the data. It is free. It is highly secure. It's free from manipulation. Now, it would make our world a whole lot easier when you have all of that. So there's a technology that renders that kind of service. It's called blockchain. Now, we've heard of blockchain. Blockchain is popular, particularly when you are dealing with cryptocurrency. It makes a lot of people blockchain. First thing that comes to your mind is Bitcoin, Ethereum, Dogecoin, BNB, Litecoin, and all of that. Okay, Luna that crashed recently, and a whole lot of cryptocurrencies. But blockchain offers a whole lot more than that. So what is blockchain actually? So we can basically refer to blockchain as a special kind of database. Now, a special kind of database in the sense that it is not so similar to your regular database system now. So it's essentially a digital ledger. So a ledger is more like a record of different transactions or different things that is done, that is duplicated and distributed across the entire network of computer systems on the blockchain. So some people might refer to it as a peer-to-peer network. So generally, when we talk about blockchain, we're talking about a database that is decentralized and distributed. So when I mean distributed, is that it is duplicated or saved in multiple places at the same time. So imagine you have an industry with a database and you have about 10,000 computers. So meaning distributed in the sense that everything about your database is spread across those systems. So everybody that has access to those systems can see the database. So basically you are saving the same information across many locations at the same time. Now, this is actually very cool and it gives some form of security, and we'll see why just a moment. So now also blockchain saves information in form of blocks. So you can have a first block then that contains some form of information. Maybe that data is saved or is worked upon, or something is done on it, or maybe something is added to it. You create a new block. So It's creating a chain of blocks, chain of blocks, chain of blocks, just like that. So the SS blockchain. That also adds some form of security, and we'll get to that in a moment. So each block in the chain contains a number of transactions, and every time a new transaction occurs on the blockchain, a record of that transaction is added to each participant's ledger. So we're talking about each system. So basically, once we make changes to whatever data we have, or we add in a new data, it reflects on every of the networks attached to the blockchain. So now the goal of blockchain is to allow data information to be recorded and distributed, but not edited. So in this way, blockchain is the foundation for immutable ledgers, or a record of transactions that cannot be altered, deleted, or destroyed. So generally, what we can say is, now we talked about having the information saved in multiple places at the same time. So let's imagine that is our case scenario. So I have a blockchain across a peer-to-peer network, and I have about 3 systems that allows me to see all of that information and exchange information between one and others. Now, let's say someone gains access to some information, or gains access to one of the, or an hacker gains access to one of the computers and the network, and it changes the data present somewhere, and he manipulates it. Now, what comes into play is, once that happens, there's sort of like a cross-reference that occurs around the system. So it's basically just changing that information on one end. On the other 2 ends, is not changed. So immediately it is flagged as some form of suspicious activity, or or fraud, or someone is trying to hack into that information, and immediately it is detected. So another point is the blockchain storing information in blocks, block upon blocks upon blocks, makes it in a sense that you don't want to change the previous block. So probably every change is actually you creating another block. So that way you can actually monitor what happens. So you can't go back to change something that has been done before. So it reduces a lot of manipulation, particularly from malicious attacks. So every time you do something on the blockchain, it is saved, and you are not allowed to change it unless maybe there is a mass amount of people on the network that allows that change. Basically, that's what happens. So now, data science and blockchain are almost made together. Now, the problem of data quality and availability and security, amongst other many problems, is solved by blockchain technology, whereas data science can provide tools that make it easier to access data in blockchain and carry out whatever analysis that you want to carry out. So in this way, blockchain already solves a lot of problems. Make sure you have high quality data that is not easily manipulated. Another feature about blockchain is that blockchain makes sure that data present in it is usually well structured and well organized. So it's easier for a data scientist to pull information from blockchain because they're well structured. Now it is available and it is secure. So you can have an high degree of certainty that, not 100%, but at least maybe 80, 70, or even up to 90 at times, that, okay, whatever data you are pulling from the blockchain system is actually secure, it's accurate, it has not been tampered with. Now, so, okay, yeah, so these are some of the things. So we are saying blockchain records and validates data. Data science can help you analyze that data. So recording and distributing data immutably. Once that is settled, then you can extract those information from structured and unstructured data and be able to use it for something good. So data integrity, data prediction. So you have real-time transaction, allows you to do in-depth analysis. Secure and transparent transaction enhances efficiency, improves data quality. And use cases, we are seeing crypto, payment wallets, storing patient data, even in terms of maybe land properties and all of that. So you can build predictive analysis models using machine learning. So in depth to that picture we just saw. So blockchain ensures data is immutable. Once it has been validated, this prevents all or reduces the tendency of data present in those blocks to be tampered with or corrupted. So you already said something about that already. Once it has been stored already in the database, it is designed in such a way that they don't expect you to want to change whatever information that you've put in there. If there's something that is going to happen, you are basically going to create a new block. So meaning that I can go through, okay, at this point, something was done here, then at the next point, this was changed. So this was a status before, then this is the new status, rather than me having a new status and overwriting the entire thing, whereas someone can't see the change. But in this case, I can follow changes that occur with the information I have, or in terms of transaction, for instance, a good example. So we can see changes that occur in transaction. So maybe I'm transacting Bitcoin, for instance. So I can tell that, okay, at this point, Wisdom Idris, okay, not Wisdom Idris, I have an address that, okay, this is the address that initiated this transaction, that initiated this transfer at so time, at so wherever. This was the amount it transacted, this is how much was left with, then was moving towards maybe Sunday, for instance. Sunday received 2 Bitcoin from so address, or Sunday's address received 2 Bitcoin from so address, and this was what he had left, and all of that. So all of those things are monitored. You can see it. Everyone literally can see it. It can't be manipulated and it can't be corrupted. So data stored in blocks, we've also mentioned it before, is usually well structured. So this makes things easier for a data scientist. Now, blockchain also allows data to be traceable. So data stored in blocks can easily be traced where it originated from, whatever has been done with the data. It might be a transaction when the asset was transferred, what address made the transaction, and where it was sent to, amongst many others. Another good example where this particular feature might apply is, let's say, in the food industry. So maybe they notice that people got sick from eating a particular food, or the particular food, let's say the brand, and or maybe where some form of things happened with consumers. So basically, if this information is stored in blockchain, they can narrow it down. Okay, so we have a brand, maybe they sell Indomie noodle, Indomie, they sell biscuits and all of that. Okay, Indomie cost problem. Now, what they can do is, this information is stored. Now they can track back everything that happened. So, okay, where was the source? Were there stops along the way? And where did they stop by? Did they stop here? Was it expected to stop here? And all of that. So that way it makes it faster for them to trace that, all right, okay, this person's information, this was where probably the problem came from. They stopped at this point and maybe someone interacted with it. Some of those things, it comes into play. So you are able to trace information as it occurs. And I think blockchain makes real-time data analysis possible. So real-time data analysis is extremely challenging. The best approach to identifying scammers is to observe changes in real time. So real-time data analysis is usually difficult. Trying to monitor something as it occurs is usually difficult, but blockchain makes that possible for you. So you can literally observe what is going on per time. So you can monitor, and it also helps you to identify scammers or suspicious activity in real time. So with blockchain's distributed nature, businesses can discover any inconsistencies in their database from the start. Which is cool. I mentioned it earlier, where in the sense that if you are having asset and you're changing something on one end, it doesn't necessarily mean that changes have occurred on the other end. So immediately abnormalities can be quickly flagged. Okay, there's an abnormality here, what's going on, and it can be traced to whatever source it has come up with. So generally, blockchain makes data and everything secure. It solves a lot of data problems in general. There are a lot of use cases for blockchain and data science. You can see it in health systems where you store patients' data in blocks. So it makes sure that patients' data are not altered. It is not changed. The patients are safe. Okay, this is my information and this is that. Nobody, unnecessary people don't have access to it. It's probably have it. Okay, some use hashing algorithms, but having a private or a public and a private key that allows some form of security. Another use case would be in probably land property. Let's say you're trying to register maybe a property as your own. You know, Nigeria wants to do some of those processes. It takes time. You have to write this, write that, get that to a particular government official, then they process it, we sign, somebody is going to record it somewhere in some paper, or all of that. It makes the process long and it is bound to human errors. But if everything is done and validated on a blockchain, on a blockchain, you can be certain that, okay, everything there is secured, everything there is working fine. Then even if there are going to be changes, now you can monitor those changes. So maybe there was an error and you want to change, basically making a new block. So they know that, okay, this happened, this was the reason for that. Then this is a new block contain maybe a more recent information about whatever happened. So once again, incorporating blockchain and data science together allows data traceability. So it makes which allows people to do real-time analysis. Next thing, it ensures the data is accurate. So you can say that, okay, whatever model or whatever prediction or whatever decision you made is probably going to be correct. So allows data sharing smooth and easy. Then it improves data integrity. So generally, this is some of the cool things about having data science and blockchain working together. It's a relatively new field. There are a lot of opportunities yet to be explored with data science and blockchain. Thank you very much. Are there any questions from anybody or suggestions?
Yeah. All right, thank you. Thank you, Mr. Idris, for that wonderful presentation. If you have questions for Mr. Idris, you can wait till the end of the meeting, till after the second speaker has spoken, to be able to ask him your question. And in place of no question, is the second speaker around now?
No, it's not here yet. I'll get him in a minute.
All right. So if there are questions, Mr. Idris can still keep taking the questions till he comes.
Hello. Good afternoon, everyone.
Yeah. Good afternoon.
Can anyone hear me?
Now we can hear you.
Okay. So I'd like to share my screen.
All right. So the second speaker is here.
Oh, okay.
Yeah. So
can we ask questions?
I know the second speaker is on right now, so I have to hold on a bit.
Okay. Okay, can we also see my screen?
It has started, but it's not yet showing your screen. Yeah, we can see your screen.
Okay, good afternoon, everyone. My name is
Abidin
Bello, machine learning engineer, and also a data consultant. So I'll be speaking on data science for blockchain, and the team under it is having a clear understanding of the situation that has to do with data science and blockchain. But before I go further, I would like to say a big thanks to Bincom for inviting me to speak. I'm really honored and I really appreciate the invite. Yes. So data science for blockchain. So just an introduction, a brief overview of what it has to do with each other. So blockchain technology, well, Mr. Idris has really nailed it. I give him a thumbs up for that. He has really said basic things of blockchain and also data science and what they have to do together. But I would also be saying few points because I cannot actually say, oh, everyone is still learning. So blockchain technology and data science go hand in hand. But how many and what kind of reward use cases are there currently? So in recent surge in the decentralized finance where we are to use of, let's say, the cryptos and the likes. There's been an expansion of Bitcoin and other cryptocurrencies, and the ongoing NFT mania, which it's also it has died down. Don't let me say died down, but it's still coming up. Have all contributed to the current interest in the blockchain. So, from the standpoint of a data scientist now, blockchains are also a fascinating source of high quality data. Just for those that make transactions through Binance, you could see the quality of transaction that goes every second from those P2P agents. So, and it can be used for a variety of intriguing challenges utilizing statistics and machine learning also. So, however, what are these precise issues? And is there enough room for data scientists to establish themselves in this blockchain sector? So I initially started as a data analyst, then moved on to the data scientist aspect. Then early last year, I tend to develop interest into blockchain and what it has to do with data science. So, and IFE assessment of this current state of affairs and the trends that are developing nexus of data science and blockchain technology is provided in this presentation in an effort to provide answers to these issues. So, data science. I won't be saying much, just to explain, to simplify it so we understand. So, there's so many data science definition, but I just stick to Casey's Cookcroft definition, which says data science is the discipline of making data useful. Just adapt it, just get the data and bring out meaningful insight from the data. Through that the data is useful. So, given the scope of this description, a more in-depth breakdown of various ways that data science is applied could be beneficial. And Cookcroft established a classification for data science applications, and one of them is the data mining / descriptive analytics. So in data science, to even achieve a goal or to make insight from the data, you must perform an exploratory analysis on the data, and it is known as EDA. This is used to find unusual patterns in data. Just for instance, comparing just the data of, let's say, 100 rows at least, from that, looking at that data, you just deduce, okay, this data is actually talking about this gender. Or let's say data of 1 million rows, you could not even see 1,000 to even think of what the data is saying. So that's where the skill of analytics and skill of analytics comes in, and statistics also. So now on to blockchain. According to Wikipedia, the term blockchain refers to a growing collection of data known as blocks that are connected through encryption. Now, on peer-to-peer computer networks, blockchains are implemented as decentralized, distributed, write-only databases, and it has historically been used as ledgers to record cryptocurrencies transaction from Bitcoin to Ethereum to Dash and other coins. So today, however, there's lots more of application for this technology. And sorry. So, blockchain technology and data science. Okay, so Yes. Okay, so this, let me just move to the next slide. I thought my video was on, sorry. Or is it important I continue like that, or? Hello? Is anybody there?
I'm here, sir.
I said, is my video compulsory or?
Your screen is showing perfectly, sir.
Oh, okay. So now just to be focused now, data science and blockchain. Blockchain by design provide various advantages that are significant for data science applications in comparison to conventional data sources, such as high quality data, traceability, built-in anonymity, and large volume data. So for high quality data, all new entries go through rigorous blockchain-specific validation procedure enabled by one of the several consensus mechanisms. Once certified and accepted, these records become immutable, whereas no one can change them for any reason, just good or bad. Just a case of a scenario where I made a transaction in crypto for a scam actually. So I had transferred the coin to the guy expecting him to pay, and he just flagged out. So I could not even raise an exception that, oh, this guy scammed me or not. So that's one of the reasons. And blockchain data is often well organized and properly recorded. This makes the life of data science who deals with such data considerably easier and more predictable. So now moving on to the traceability. Blockchain records include all of the information recorded to track their origin and context, such as which address started a transaction. When it's occurred, the amount of the asset is transferred and which address received that access. So for those that make use of, I'm just making use of the Binance app where before you even make any transaction, you must have the receiving address at your own end just to make a successful transaction. So furthermore, the majority of the public blockchains feature explorers, that is website where nobody may review each record ever been made on individual blockchain. For example, the Bitcoin and the Ethereum, and also the Ripple explorers. And for the anonymity. So blockchain do not need users to submit any personal information such as significance in the world, where maintaining one's privacy has to become a major concern. So to even have a blockchain account, it does not really need to even know your address. All it is just a unique ID. And from the standpoint of a data scientist, this helps to alleviate the problem connected with certain legislation where it comes to data security and the like, you revealing the details of this user. That tackles it. And for large data now, so when it comes to machine learning for data scientists, to train models, many machine learning methods need vast volumes of data. And blockchain, when it comes to blockchain, blockchain does not deal with maybe megabytes, it deals with terabytes and petabytes of data. So this is not an issue. Now, collecting data from blockchain is very tricky, but there are many options. So collecting data relevant to the problem at hand is, let's say you want to deal with, so you're not taking a fraudulent or, okay, let's now say the normal data, the known apps, let's say the known apps now, they tend to use a very common algorithm that is the churn data, the churn model, where to see if this person will default or not. So now let's scaling it up to the cryptocurrency level where they tend to loan cryptos out. So how do you now get the data of this? So for models that would have to work on large data, blockchain provides that amount of data. So programmatically collecting larger data sets are suitable for data science purpose, and it can be daunting. Being such skill is actually required, whether software or financial resources. So now, to get this data, you can make use of data sets that are already prepared by someone else, and you could also use blockchain-specific APIs or ETL tool. Okay, there's this one. TradeView, yes. You could make use of TradeView API to scrape updates on cryptocurrencies prices and also commercial solutions. So, descriptive blockchain analytics. The age of descriptive blockchain analytics is now, and blockchain is a very new technology, and it's possible that we are just starting to appreciate the value of data it provides. It is essential to be able to execute descriptive analytics, the efficient of collection, summarization, and visualization of data at this early stage. Well, unsurprisingly, cryptocurrency and regulatory compliance have dominated the bulk of these use cases for descriptive blockchain analytics. So to assist Bitcoin enterprises, financial institutions, and law enforcement authorities with following frequent tasks. That is, now we're merging the purpose of data science and blockchain together. So you could just help them in tracking and visualizing the transfers of money between addresses to see or to trace down stolen money on purpose. So now moving on to the next one, by labeling blockchain addresses and associating them with physical locations. Let's say you make use of the long and lat details of the data, and also real-time alerting about unchained events. Let's say there's this large volume of crypto that was transacted. Though large volume of crypto, let's say above $4 million, takes time to. It does not go at once. You understand? So that you could detect that, and also cross blockchain search with a common data model. Yes. Now, numerous academic research on machine learning and blockchain, but we're going to be talking about few practical applications. Yes. Numerous academic papers have used machine learning to solve different blockchain-related issues. So, for example, Lutz et al., that is him and three other researchers, divided these issues into the following three categories in their thorough review work. And the first one is cryptocurrency price prediction, where you tend to predict the future prices of cryptocurrency. And the second one is address identity inference. Or the second one is anomaly detection. So now, for those that love or that has interest in data science and also blockchain, so is there really a need to combine the two? Yes. So according to Forbes, they identified 13 involving and emerging use cases for blockchain, such as the management of artists' rights, that is the NFT, cross-industry data consolidation, decentralized finance, supply chain management, user authentication, password management, electronic health records, and so on. Now, an army of specialists who are skilled at making data usable for data scientists will be needed to keep up with all these changes. That's where the work of a data scientist comes in now. So blockchain makes the data ready for the data scientist. So this even eradicates the problem of data not being available. So now, the range of interesting and unsolved blockchain data science problems is enormous. So, and some are still yet to be discovered. So, in addition, many of those issues have not yet been defined. So, if you are considering becoming a data scientist and exploring the fascinating world of blockchain, the time is now. So, check out the career sections on websites of many businesses listed in this article. Okay, I'll post a link to the article after this presentation. And if there are any vacancies opening for data scientists, so that may be useful for anyone watching or being present here. And so in conclusion, blockchain technology has the potential to alter numerous sectors and businesses' procedures. So now is the ideal moment to pursue a career as a blockchain data scientist. Yeah, thank you.
Thank you, sir, for that wonderful presentation. And I'm sure a lot of us have gained a lot from the speaker for today. So now we are at the point of asking questions from the speaker. So if we have any questions that we would like to ask the speaker, we can bring our questions forward, either from the first speaker or the second speaker. But now is the time to ask your questions. I think I saw a question in the chat box the other time. What's the difference between I don't know what it is. So if there are questions, please, you can bring your question. You can ask your question now. So nobody has any question. If there are no questions, you can reply with no question so that we can move on to the next thing. All right, no question. All right. Okay. So I'm about to share my screen. So give me a moment. All right, Sam Oladipo, your contribution is taken.
I'm sorry, Tolulope, I have a question. I dropped it on the chat box. Did anybody see it?
Yeah, I wanted to, I don't know if it's deleted or something. You can ask the question again.
Okay, I've seen the question. Blockchain and Hyperledger. Sure.
Yes, sir.
Okay. So I don't know much. Maybe it's external speaker might say more that. But what I do know is for Hyperledger is more of a private blockchain. So it's more like organization that enables you to make a private blockchain in that sense. So so if you're saying blockchain is more like the decentralized and distributed database. So it can be public and it can be private, but in most cases, it's generally public when we talk about blockchain. But with Hyperledger, it's private. So people that have access are more like predefined users that are given access to the system in general. But with normal blockchain now, it's usually public, usually, but you can also have it as private. Do you get it?
Okay, let me add to what you just
Yeah.
said. Yes, so while blockchain is a concept which can be implemented in many ways, it is basically a technology that stores data, that is blockchain. On the other hand, Hyperledger uses blockchain as its own database with another logic which it performs, which is a platform on its own. You understand? So now blockchain is normally used to store voluminous data, and while Hyperledger uses blockchain as its own database.
Okay, I get that now. But sorry, I have another question. So who are those people that use this Hyperledger?
I think I will direct that to Mr. Bello. Hello, sir, are you there?
Yes. I was trying to. So your question again, sir. Hello? Hello?
Yeah,
Yes.
so I said who are those people that uses this Hyperledger?
Hey, how do I describe it now? Okay. They are just would I say, let me just put in a word, in the sense of opportunists, you understand? Yeah, there are some it's more of like opportunists looking for a secure way to keep their data, and these are large firms like the fan companies now. You understand? The fan companies like Facebook, Google, and the likes.
Okay, so like the healthcare's financial.
Exactly. Yes, those has to do with data of the public that won't allow you to understand. So they use blockchain as their database just to make the security more.
Okay, thank you very much.
You're welcome.
All right, yeah. So is that all? Do we all then have any other person have questions? So in absence of no question, we are going to share some of the services we render at Bincom Dev Center with everyone on this call right now. So just give us about 5 minutes of your time and watch this video. Thank you.
In Nigeria. And our major objective at Bincom Data Center is to produce over 1,000 quality tech individuals every year. These people are highly employable, globally attractive, and highly sought after. The tech ecosystem, tech talent, and guess what? Average salaries of software developers are as high as £35,000 per annum, and this is at the entry level. The opportunity for tech talents are endless, both locally and internationally. This means that the tech
Sorry about that, my internet got cut off.
Sorry about that. My internet got cut off.
Talents that they need. This is why we started the Bincom Global Tech Program. The program for skills, gain experience, and gain exposure. The program spans between 1 to 2 years, and during this period, trainees are taken through an in-depth curriculum in their chosen tech tracks and also in development of soft skills required for them to become globally attractive in the tech ecosystem, both locally and internationally. This program helps trainees to learn tech skills, gain relevant tech experience, and also explore to the endless possibilities and opportunities available in the tech ecosystem all over the world. Listen to some of the testimonials of our past trainees.
Yes, I had high hopes and expectations while joining Bincom Academy, and trust me, believe you me, yes.
Knowledge tracks that you can choose from. Some of the technical knowledge tracks include the data science track, which is starting with Python. We have the backend track starting with PHP, the front end mobile app track starting with JavaScript, the DevOps infrastructure track. We have the UI UX graphics track, and also the software testing and quality assurance track. And apart from the technical and software programming knowledge tracks, we also have business knowledge tracks that are equally highly paid across the world. And some of them include the project, service, and product management track starting with Agile. We have the digital marketing, performance marketing track as well. That's interesting, right? Yes. This is a highly intensive program. You need to be able to commit at least 40 hours every week to the program. You can choose from our various shifts. We have the regular shift, which is the 40 hours weekly, 8 a.m. to 5 p.m. on weekdays and 1 to 2 Saturdays a month. We have the night shift, the 40 hours weekly, which is 5 p.m. till late on weekdays and 1 to 2 Saturdays every month. We also have the majorly weekend shift, which is 40 hours weekly, 10 a.m. to 8 p.m. Saturdays and Sundays, and then 4 hours every other weekdays. We also have other flexible shifts based on your availability. Yes, all you need to start are a laptop device and a passion and a hunger for IT. Wait, it gets better. We have various financing options to help you cover the cost of the program. Though the program is not free, you do not need to have money to be able to apply and be admitted to this program. The total cost of the Bincom Global Tech program over the 1 to 2 years period is 1.2 million naira. And we have one of the financing options available is the income sharing agreement, which means that the company will sponsor you through the entire program and you only start paying when you start earning income. After the program, this means that aside the skills, the experience, and the exposure, the company is also willing to invest their money on you. It doesn't get better than that. What are you waiting for? Hurry up to bincom.net/globaltech and register to launch your global tech career. Thank you.
Right, thank you. So you have a global tech program that Bincom runs. So if you are interested in doing it, you can register on www.bincom.net/globaltech and get more information on the program. Thank you for joining. We've come to the end of this community events, and I hope you guys have learned a lot. I did too, and I hope to catch you at the next community events we have. Thank you for joining.